Hi everyone, this is Thailand. In this video, I want to talk about the intuition behind hypothesis testing. So, if you understand this concept, the rest is all applying the formulas to the specific problem. But the intuition is very important because this shows you why we do what we do in hypothesis testing. I'll begin with a game. Your friend came up with an idea. He or she will roll a dice. If a 6 comes up, you will lose. Right? You will lose. Otherwise, you will win. So, your friend claims that it's a fair dice. Then, it is very good to play this game for you because the probability of having a 6 is 1 over 6, and the probability of not having a 6 is 5 over 6. So you have a great chance to win the game. Of course, these probabilities are under the assumption that the dice is fair. So you play this game for 10 times and you lose all 10 games. Okay, you go mad. You say that, how is that possible? Your friend just says it's just simple probability. Okay, you are not convinced. So then the rest is just applying the simple ideas of hypothesis testing. You say that, okay, let's do a hypothesis test. H0 is dice is fair, and H alternative is dice is not fair. And let's assume that your hypothesis is true. Okay, you say that the dice is fair, then let's test it. So let's assume H0 is true. So therefore, having a 6, the probability of having a 6 is 1 over 6. Then you calculate the probability of losing all 10 games. So probability of having 10 consecutive 6 outcomes, and this probability is 1 over 6 to the power 10. So it's like 1 in 100 millions. It's a very low probability, so you are actually not convinced. You say that, no, this cannot be true. I reject the hypothesis that the dice is fair. Okay, so now you just understand the idea behind hypothesis testing. Why? The idea is, propose an H0, and this H0 must include equality, right? Why? You say that why the dice is fair includes the equality, because when the dice is fair, then we have a probability. The probability of having a 6 equals to 1 over 6. Therefore, our H0 null hypothesis includes the equality. And first stage, having an H0 and HA. This is the alternative hypothesis. Okay, sometimes students tend to think that H0, the null hypothesis, is the hypothesis that has a positive meaning, like a student passes a test, or I win the lottery. No, the null hypothesis is the hypothesis including the equality. There is no other meaning, because as you just understand, we assume H0 is true, so we need an equality to assume true. Then we proceed. Okay? The second step, assume H0 true. Okay? So equality is assumed to be true. The equality in H0 is assumed to be true. Third, so we will do this with different strategies, but the idea is like check the probability of your sample and beyond. Let's say, you have a sample at hand and, you calculate the probability of that sample, but to the more extreme side, your sample and more unlikely cases. But when H0 is true, so you can ask, how do you determine what unlikely is? When H0 is true, the sample and more unlikely part. For example, when we assume that the dice is fair, then the extreme side is like losing the game for many times, because having a 6 is unlikely relative to not having a 6. So therefore you determine the unlikely part relative to the null hypothesis, relative to the assumption in the null hypothesis. So you calculate the probability of your sample, let's say. So if this probability is very small, in every question we will talk about how do we define that very. This is something called level of significance or type 1 error, but we will talk about these details later. So if that probability is very small, then I think if H0 was true, then we would not have such a very unlikely sample, right? If my friend, rolled a fair dice, then, I wouldn't lose this game for 10 times. It's very unlikely. There must be a problem with H0. There must be a problem with null hypothesis. So I think my friend cheats, okay? If the probability of the sample is very small, reject H0. If not, do not reject H0. Okay, but please be aware that the hypothesis testing is all probabilistic. There is nothing certain here. Your friend, can be maybe right. The dice may be fair, and you face an event which has a probability like 1 in 100 millions. It's possible. But with the evidence at hand, you must have a decision. You reject null hypothesis or do not reject null hypothesis. So we don't like to say null hypothesis is true, because saying null hypothesis is true, it has a meaning like it is certainly true. No, we decide rejecting or not rejecting based on the evidence at hand. We can be still mistaken, because the decision is about a population parameter, like the probability at the dice, the mean of a population, the mean of let's say incomes of all people in a country. So we don't know that exact population mean, but we are trying to have an idea about that. We are trying to test the hypothesis about that. So therefore, we cannot be certain about those population parameters. We cannot be certain about the hypothesis, but we can decide to reject or not reject based on the evidence at hand. So this is the intuition behind hypothesis testing.